So the next video in our little story here about the beginnings of quantum mechanics, we'll spend a little bit of time on the background here of two of its more remarkable figures. The first one, of course, is the New Zealander Ernest Rutherford, who was born physically as far away as you can be from what later was the center of all of this, and primarily in Europe and England and so on. I spent some time in Montreal, and was one of those personalities that was in many ways larger than life over his many years. He was also a great educator and made a lot of young people effective in this field with his own work as well. And one of his, in effect, students was a young Danish PhD graduate, Niels Bohr. And of course, the combined influence, even though these men rather were very, very different in temperament and background, they formed a connection. And this led, of course, to the impetus of the work of Niels Bohr. And so I thought I'd set this background for you before we actually discuss the work of Niels Bohr in the next video.
One of the more important and colorful figures of the early days of quantum mechanics, of course, was the New Zealander Ernest Rutherford. And he showed significant educational promise as a young boy and ultimately won a position at the Cambridge Cavendish Labs. And this was something that he was the first person outside of Great Britain to be given this position, and of course this created a bit of a stir. But he was a sharp cookie, and he actually worked with J.J. Thomson on some of the developmental work before Thomson discovered the electron. Thomson, it still had to be a bit formulated exactly what Thomson had discovered at that time, and again, the whole idea of an atom being in its indivisible, metal ball, if you will, it took time to fix. After that, in 1899, Rutherford moved on to McGill University in Canada, in Montreal, and among other things, he, of course, was the MacDonald Professor of Physics, his first legitimate job, and which paid him half decently, and so then that got him a chance to get married, and then he there discovered first alpha and then what he called beta emanations from the atom. Now, it took some time to characterize what these actually were. They were certainly finding helium gas around these materials like thorium and so on. But it took until 1913 before they identified, as you see in this diagram, the alpha particle being actually a helium nucleus. So Rutherford's work on the initial aspects of radioactivity and so forth was well received, and he won the 1908 Nobel Prize. However, his most famous work arguably comes after that, when, of course, he did the gold foil experiment, which allowed his primary contribution, of course, was the interpretation of it, that you have this very, very dense positively charged nucleus, and this completely changed our perception of the structure of atoms, and of course coupled nicely with Thomson's work of finding the electron. So, and again, it is remarkable that all this is done, of course, 120 odd years ago with equipment that today we would find pretty archaic. So in the following whiteboard demonstration, I'll show you a little bit about how they were thinking when it came to this whiteboard, this gold foil experiment, because it's just an interesting interpretation. This is, of course, not verbatim from how the experiment was done, but more of a representation of it. And you get a chance to see how we discovered the nucleus of the atom.
By the turn of the century, Rutherford had returned to England and ended up at the University of Manchester. And here he and his grad students came up with the following experiment. Sometimes when you want to find out what's going on with something, you need to throw things at it and see where they bounce off. And we're dealing with very, very small items, and so this is what they did. Now, of course, Rutherford was an expert on atomic decay, and so he came up the idea of a source of alpha particles. These are helium nuclei that are ionized. Okay, so you have 2 protons and 2 neutrons. So this is an atomic cannonball. He then, and again, there's certainly contributions here from his grad students, to be clear. They put a film of gold. Now gold is malleable. And this allows us to have thin sheets. Its atomic structure is such that when you pound it flat, it doesn't crumble. And this makes it very, very thin. If you didn't make it thin, then there's no way the alpha particles would ever penetrate. They just hit it and either be absorbed or whatever, and that'd be the end of it. And gold is also atomically dense. And so it's not going to move very much. The alpha particle is very small in comparison. Now let's start off first with what they thought was going to happen. So we have the, as he would call it, the plum pudding model. Now in North America we don't eat too many plum puddings anymore, so we'll call it the chocolate chip cookie model. So what you have then is an atom that would look like this, and it would have regions within it that have the positive charge. The expectations then would be that you would get this alpha particle would come to the film here, and there would be very minor scatters. Okay, so we expected almost all alpha particles to scatter a little bit. This is not the case. And this was one of those days where, in many ways, the scientific world changed. So let's have a look here at what they did find. We'll get rid of our chocolate chip cookie now here. And the effect that they thought they were going to see. Instead, what they found was the vast majority went straight through. You had some that were deflected significantly, and some that even recoiled. So most were unaffected. A few radically scattered. So, this was, to put it gently, unexpected. And I guess that the results of experiments like this that's the most fun. Remember too that the result of an experiment when a discovery is made is not eureka, it is something usually along the lines of, that's funny, it shouldn't be doing that, or something to that effect. You think you've made a mistake. This wasn't a mistake. And clearly, the interpretation of this was that the nucleus, where the positive charges were contained, was very, very small, dense region, and the rest of the atom was basically empty. So let's look at how this changed our concept of the atom. So we first have our chocolate chip cookie here. And it has its positive charges in it. And this moves to a completely different situation where you have very dense region and some type of a cloud of electrons. So a very dense positive center. So this was then the discovery of the nucleus. And I'd say it quite candidly, this is one of the most profound discoveries of atomic structure in history. We saw it as a guesswork in this way, and suddenly now we had exceptional evidence that the atom was structured completely differently, that this was utter nonsense. And just a few years later, this was, 1906, 7, 8, whatever, 5 years later, now we have the electrons in some kind of orbital situation. And so the structure of the atom, which was an utter mystery at the turn of the century, is now revealed in some detail. Now we have scientists who come up with clever experiments to understand the universe more effectively, and those people exist. We've seen it with Albert Michelson and others in the past. And we also see experimenters who come up with very clever technologies to make our lives easier or better or more entertaining. And there's a difference. But the cleverness in both different groups is arguably equal. And Rutherford had this in spades. Whether he had it himself or instilled it in his people is not necessarily an issue. And and this changed everything in many ways to where it stood from there.
The next person to enter into this story is one of the large figures, of course, in the early days of quantum mechanics. He survived until 1962 and was thus not only just a father of some of the early theory, but a great teacher of the concepts, and is one of the grand old men of science from the time he got older. His name was Niels Bohr, and he originally was, of course, from Denmark and did extremely well in his work, publishing even as early as the age of 24. And when he arrived at a chance to study, he decided immediately to go to Cambridge to get a chance to study with the great J.J. Thomson, who roughly 10 years earlier or so, maybe 15 years earlier, had discovered the electron. Now, when he got there, of course, there was naturally some language difficulties, but not only that, Thomson, like a lot of scientists, you move on a little bit from your previous research. And here you've got this eager, verbal, busy talking young scientist, and he of course told Thomson he had found a mistake in one of his early papers and wanted to talk to him about it and all the rest of it. He gave Thomson a copy of his thesis, and he found fairly soon that not only was he not Thomson wasn't paying attention to him, but really didn't spend a lot of time with him because he really didn't want to talk about whatever mistake may or may not exist in his older papers. And Bohr found that Thomson hadn't even bothered to read his thesis. So he was kind of disappointed. Of course, there's a naivete there too. You have a highly established scientist such as Thomson, and here you've got this newly minted PhD, and these two are at completely different parts of their professional lives. And so Bohr writes to his wife in his diary among how he felt Thomson had no use for him, that he didn't feel he was accomplishing a great deal at Cambridge. And he saw a lecture by Rutherford and was impressed by him, and so ultimately he was kind of despairing a little bit, and there was a suggestion that he might go to Manchester to see the great man. And Bohr, on one hand, wasn't quite sure what the point would be, because Bohr's research was theoretical and Rutherford, of course, was a dedicated experimentalist. And one of them said, the old Rutherford could teach you more than you think. And so anyhow, the story goes that Bohr went off to Manchester on a whim, really, and it just happened that the two of them hit it off, that their personalities clicked. Niels Bohr and his brother were exceptionally good footballers and loved the sport, and of course Rutherford was the biggest fan ever. And so you had this other connection outside of the subject, and and Rutherford basically gave him the run of the place, and this really changed how he was allowed to feel about things. And Rutherford's interpretation of some of the experiments Bohr saw differently, being theoretical, and this, of course, was what happens when you have young minds thinking about things, just like it was for Rutherford, 15 or 20 years earlier. The story also goes from some of the diary writings that Bohr would write that once a week Rutherford would come along to talk to his graduate students, and they would have a chance to discuss their experiments with him. Now we have to remember this is 1910, 11, whatever, and the behavior and expectations of people were different than they are today, and the customs. Rutherford would come along, of course, in his three-piece suit and his pocket watch and his cigar and all the rest of it, and he would sit in the chair, and the two graduate students, as Bohr would write, would basically stand at military attention as they tried to explain their work to Rutherford. So the whole thing is a bit hilarious in a way, how things were. But of course Rutherford had earned his position, and there's also stories about at a later time Rutherford, when he wished to had a big voice, and some of the highly sensitive equipment would get damaged or vibrated or decalibrated if he spoke too loudly, but no one had the temerity to speak to him directly and ask him to moderate his tone. So there's a famous picture you see that has this sign, "Please speak softly, sir," above it, so he could see the sign, but he was not sure of the author. So there's these types of stories. When Rutherford got sick with a strangulated hernia and ultimately passed away in 1937, and Bohr was at a conference, and he was asked to say a few words about him, and it was difficult to Bohr to keep it together because Rutherford had meant so much to so many, not only technically, but as a man of good souls, and as an teacher and a leader and a mentor, and he truly was one of the great men of science. Rutherford was very much a man of his opinions and was quite prepared to say what he thought about things, and upon the discovery of the atom by Bohr's work, which we'll talk about in the next video, Rutherford said that Thomson's ideas were now cast like old wood, only to be seen in a museum. Thomson, of course, was not so charitable and felt that Bohr had done his work without proper foundation of the understanding of the atom. So nevertheless, and these, of course, science is not just theories and equations. It's also about people and personalities, and you can see in this story at least how they mesh in different ways. So Bohr is famous in the 1920s for a series of verbal debates with Albert Einstein discussing quantum mechanics. Einstein, of course, did not accept the probabilistic aspect of the quantum mechanical model in the 1920s. And so the development of quantum mechanics then proceeded in largely without him. But Bohr was always a little frustrated because he would come to Einstein and have these discussions, and he was never able quite to convince Einstein of this direction, and he saw that as a challenge. Now, Bohr was a man who figured things out by talking. He had a significant writer's block and loved the discussion of ideas. He created the Copenhagen School of quantum mechanics, and was certainly a force all the way through the 30s. Made a daring escape from Denmark from the Gestapo during the occupation, and ended up in the United States eventually, as did seemingly everybody else. And so he had an incredible career right up to his death in 1962.
So there you have some of the more colorful figures. Lots of interesting little stories related to Rutherford and Bohr over the time, and I'm sure there are many others that I didn't neglected to tell in this particular story. Nevertheless, remember that science may well be principles and mathematics, but it's also human, and we also have people involved, and the things that happen between the people and the interactions and who gets along and who doesn't get along and how all that rolls out is often part of how research develops, and we need not to forget that. Thank you so much for watching.